Hello and welcome to Mr. Abadir's Kitchen Chem Mystery. Today, using household items you would easily find in your home, such as baking soda, vinegar, salt, rubbing alcohol, and distilled water, we will preview the entire year of chemistry. Let's get started. Next, we're going to consider baking soda and distilled water. You'll notice in this weighing dish that we have some baking soda already poured out, and you'll see that some of it is powdery and some of it is chunky. We're going to use this scoopula to take a little bit of the baking soda and put it into this Erlenmeyer flask, which has about 100 milliliters of distilled water. Because we want this to happen faster, what we're trying to do, we're going to swirl this around, and we'll take a look inside of the flask, and we'll notice that the baking soda has disappeared. Now we're going to take the rest of the baking soda and pour it into the Erlenmeyer flask as well. And you'll notice that you see a lot of the baking soda in there. We'll try our last strategy that we used before to swirl. And as we swirl, we realize that it's not the same result as we had before. Some of the baking soda just will not dissolve. Now what we'll do is we'll take some of this solution and we'll pour it into this beaker, and we'll save it for a coming step. Next, you'll notice that we have about 80 milliliters of vinegar in this smaller beaker, and we will save this for a future step as well. Next, we'll focus on isopropyl alcohol or rubbing alcohol, and in this graduated cylinder on the left, we have 30 milliliters of the solution. You have to hold it at eye level to see it properly in volume, and also you'll notice on the bottom that the marker has smudged wherever the alcohol was spilled onto it. On the right, we have distilled water, and we have 20 milliliters of that. Distilled water means that it has been evaporated or purified so that it is pure water without any other ions or anything dissolved into it. What we're going to do is we're going to pour both of these together. So we have 30 milliliters of the isopropyl alcohol, and we're going to pour it into the 20 milliliters of the distilled water. And then we'll look at the final result. So all you math whizzes out there should be predicting that this is going to be a total of 50 milliliters of solution. But if you look carefully, and if we use a darker background, we will see that it is below 50. It's roughly 49. You're going to have to explain that one to your math teacher later in the year. Now we'll simply pour this mixture into our beaker that's labeled isopropyl alcohol and distilled water, and we'll be ready for our next step. We now have our three solutions ready. We have our baking soda with distilled water, we have our vinegar, and we have our isopropyl alcohol and distilled water. We're going to now introduce something called a conductivity tester. This tests whether a solution will conduct electricity. When you dip it into the solution, if it conducts electricity, current will flow between these two prongs and it will light the light bulb. We'll start with the alcohol and distilled water, and we'll notice that there is no conductivity at all in that solution. Now we're going to go to the vinegar, and we see that the light bulb does go on dim. And lastly, we're going to go to the baking soda, and we're going to see that that lights up very bright. So we have a bright, we have a dim, and we have a nothing. Next, we're going to use universal solution to determine if these solutions are acidic, basic, or neutral. This solution will change color. The universal indicator will change color in acids, bases, and neutral. You can actually make your own indicator out of red cabbage, which we will do later in the year. So I'm going to drop a drop of this into the baking soda solution, and we'll see that the color is bluish. We're going to drop some into the vinegar, and we're going to see that the color is reddish. And lastly, we're going to drop some into the alcohol and water, and see that that is more towards a yellow color or orange. orange. Next, we're going to take some of the vinegar solution and we're going to pour it into the baking soda and distilled water solution, which is in the Erlenmeyer flask. Then we're going to use a stopper and put it right on top of there and see what happens. Take two. Take three. Got it on third try. Next, we turn our attention to temperature. We're going to use a lab quest, which is connected to this temperature probe. It's currently reading the temperature of the room to be 26.2 degrees Celsius, which is pretty close to the normal room temperature of 25 degrees Celsius. I'm going to put this temperature probe into this beaker with the baking soda and water in order to get the temperature there. Meanwhile, I have some extra baking soda, and I'm going to put a little bit into this flask. Notice that there's still baking soda at the bottom, even though we did a reaction earlier. Let's see what happens when we add a little more baking soda. So you can see nothing really happened. I'm going to put a little more baking soda into our beaker as well. And we're going to get the temperature in here. So you can see we're starting at a temperature of 25.2 degrees Celsius. Next, I'm going to take this vinegar, I'm going to pour it into here, and we're going to monitor what happens to the temperature. You can see that the temperature is changing, and the temperature is actually going down. Final temperature that we see is 23.2 degrees Celsius. And ultimately, for our grand finale, we will take our remaining baking soda and water, pour it all into our beaker, give it a little extra baking soda just for fun. Next, we'll take these crucible tongs and we're going to pick up this crumpled up piece of paper towel. We're going to dip it into the alcohol and water mixture, carefully soaking it. Then we will take it out of here. We'll take our lighter and we're going to ignite the paper towel. Notice the color of the flame, bluish. And as we drop salt onto it, notice the color of the flame changing. Next, we take our vinegar, we pour it into our baking soda as we have in the past. We let it react, and then take our paper towel and notice that the flame has been extinguished. And this is the kitchen chem mystery.